Okay, so I'm joined here with Soroush Khanlou. We are going to do a kata together. The specific kata we're going to do is kata poker hands. But real quick, I'd like to introduce my partner in crime here. Soroush, do you want to give a quick shout out on like where you can find you on the internet? And
For sure. I'm Soroush Khanlou. The thing I'm most proud of on the internet is my blog, which you can find at mylastname.com. So KHANLOU.com. And I'm also my last name on Twitter, but mostly I just post links to my blog posts there. So
awesome. Well, I'll include both links to both of those things in the show notes. So thanks for joining me. We're going to do this kata poker hands as an exercise in sort of exercising different parts of Swift that maybe we don't touch on a daily basis. Also, we've never worked together before, which is super exciting. I'm really eager to just jump into this and sort of see which areas you're like, no, that sucks. We should do this a different way.
I'll try to be very gentle.
Okay, awesome.
No, I'm looking forward to it.
All right.
I haven't paired like this in a while. It's going to be great.
Okay, and then just a little bit of the technical setup. Soroush is on Skype, so he can't type. So I'm going to do all the typing. He's going to do most of the navigating, and we'll discuss the implementation. Just like the previous episodes, I'm using Atom to write the code, and I'm using Guard to automatically run all the tests on the right-hand side. So hopefully there won't be too much friction with lacking autocomplete and all that stuff. We do have Dash with the Swift documentation if we need it.
Cool.
So a bit about the kata in mind. We're going to be scoring poker hands to determine which one is the winner. So our input is going to look like this. We're going to have player names like this, separated on a line. So you could imagine a program that reads multiple lines, scores this game, so to speak, or this round, and then just moves on to the next one. So we're going to have two players. Each player is going to have 5 cards, and each card is denoted by a 2-character string like this. So that would be the king of diamonds. This would be the 9 of clubs, 5 of spades, 3 of diamonds, 2 of hearts.
Cool.
And these are the rules. I've actually pulled up a picture here to make it a little bit easier of which hands beat which other hands. And I think that our job for at least now would be to start off with just parsing this into something structured. Does that sound like a good place to start?
Yeah, that seems really good.
Okay, so I'm just going to write a test. I just want to, like, the simplest thing I could get would be the player names out of that input.
Yep.
So let me copy one of these lines, and we'll just slap it there, and we'll just run a bunch of tests on that one input.
Yep, that seems right.
So test parses players. So we're going to have some sort of parser. I don't know if you want to call it parser or input parser, maybe something like that.
Yeah, that seems fine with me.
And input. And then I want to be able to parse it and get back players.
Right.
So maybe parser.parse.
Right. And then you're thinking each player will have a hand, and each hand will have an array of cards?
Yes.
Okay, cool.
That's what I'm thinking.
Yeah, that sounds...
Okay, so then I would assert that...
Maybe just assert players.count equals 2. That seems like the best thing to start with.
Yeah, there we go. Now, I always forget this. Is this expected and actual?
It doesn't matter.
It does matter.
Does it?
Well...
actually, that's
not,
true. I guess
not with in XC test, it probably doesn't matter because the error messages are horrible.
Right, exactly.
But ideally, it should say, I expected to find this, but found that.
Right. Let me pull up the documentation. It just says expression 1 and expression 2.
Oh, that's horrible. Okay.
Yeah. There you go.
Okay, so it's not compiling because we have no parser class.
Checks out.
So we'll create that. And I already know that that's going to need an input, and we need to have an initializer for that.
Right. So that's all boilerplate. Cool.
And it needs a parse method that returns, I don't know, any.
Seems good for now.
And I'll return empty string. Okay, so we have a test failure. Assert failed. 2 is not equal to 0. So yeah, the error messages, I guess, make it.
Yeah.
It's not awesome because it doesn't tell me which one was which, but we'll figure it
out. Yep.
Okay, so the first thing I would say is that we need a type here because I need to do something with it, right?
Yes.
Or would this type be a string?
Yeah, maybe we could just keep it as a string for now if we want to go really hardcore TDD.
Okay. And then I need to read in this input. If we take a look at it again, I think that this could be done in a number of ways, but I'd like to play around with NS Scanner
Okay.
because it's a type that I almost never use.
I'm down to use NS Scanner. It may actually also be easier to just do like splitting it, basically. Like if you split on 2 spaces, you'll get the 2 hands. If you split on colon and space, then you'll get the name of the player and all the things. And then if you split on space, you'll get all of the cards. So
yeah, that's probably simpler.
It might be simpler. On the other hand, NS Scanner is really cool, and like getting practice with it is not the worst thing in the world.
All right. Well, let's make a judgment.
Let's try the splitting way because it seems like it would be pretty easy.
So we're going to split the string
with 2 spaces
on 2 spaces.
Yeah.
What is a separator?
I think no autocomplete. Brutal.
Yeah, I know. Let's see.
Here, I can.
String has no. Oh wait, hang on. Components separated by.
Yeah, I will like pull some stuff up on my thing as I have a playground open, so I can like maybe help guide you in that way.
Also, I need to make sure I import Foundation because there's going to be a lot of stuff that we don't realize that we use all the time.
Great call.
Which I thought this was components separated by. Okay. Yeah, Foundation
but
NS string.
That's separated by a character set. So maybe we do. Can you do like? Is there a split? Let's find out.
Let's see, Swift split.
Return input split. So components separated by string works as well.
Oh, separated by string?
Sorry, it's just separated by, but you can pass a string. It looks exactly the same. Like that should work. You just need to return that. Is it not liking that?
Oh, it's complaining that's unused.
There you go. Goodness. Nice. Right. Okay.
Yeah, I mean, part of this frustration is that we're not using Xcode,
right?
But that's fine. Okay, so at this point, then we have our 2 complete hands. Well, I'm just going to call this parts because I don't have a better name for it. And then I want to map this to each part.
Right. For now, let's return the parts and then make sure our first test passes.
Okay, that works.
Yeah, that hands. Nice.
Yay. All right, so I can real quick just say that I assert that the player names are black and white.
That's good. Maybe players.map names or to name.
Yeah, I'm thinking map name.
Yeah, I think that's right.
Something like that.
Yep.
And this means we need a type.
Yep.
Because right now I was returning a string.
Yep.
But it's not going to know what name is.
Perfect. Yep.
Okay, so let's create our type.
So we want a player type?
Yeah. And I suppose, what's your thought on struct versus classes?
I think in this case, struct is right, just because we're dealing with dumb data. It doesn't, it doesn't need to have any sense of identity. It just kind of is.
Yeah, the way I view this is like, what is your sense of identity and equality?
Right, exactly.
If a player has the same name and hand, then it's the same player.
Yeah, it's just...
Right, like value equality.
Right.
Okay, so we need a name, which is a string. We need to be able to create that from our parser.
Right.
So we're going to map this for each part that we have.
We then need to split it based on colon space to get the first half and the second half.
Do you want to delegate this off to the player or put it in here? I guess this thing is called parser. It should probably parse the things.
Yeah, maybe it makes sense to delegate to like a player parser later. But let's write the code for now, and then maybe we can refactor, given that we'll have tests.
Yeah. Okay, so we're going to say part.components separated by, what was this, a colon space, right?
Colon space.
And so this is going to be player parts.
Yeah.
And then we are going to have, the name is going to be player parts bracket 0.
Yep.
And then I don't care about the rest.
Yep.
And we'll return here a player with the name of name.
Perfect.
And let's see. And we need to return players.
Sweet. Passed.
All right. So what's next? Player probably needs a hand. Okay, so let's see. Test parses player hands. So we'll have another test. It'll look sort of similar. And we're not going to assert that exists. We're just going to grab the first player out of that. Well, let's grab the hand. And the hand is going to be players 0.hand. And I just want to assert for now that it's not nil. And this isn't going to work because we have no hand method or property here. And what is the type of this thing?
Let's make it an array of strings for now.
An array of strings, okay.
Yeah. And it won't be nillable, so I guess the test will still work.
Well, it doesn't compile at the moment because we can't create a player like this anymore.
Right, that's true.
So we need to pass in a hand, and now a hand is going to be the player parts 1 separated by a space, right?
Separated by space, yeah, that's right.
Just going back to our input. So we're looking at this as the second part, and then individual parts there.
Yeah.
Okay.
And I would
so
call
that our
hand maybe card strings, or I guess
instead of hand.
Yeah.
Yeah, I imagine we're gonna have a type here anyway.
Right,
so,
definitely.
That'll be easy to replace.
Yeah, and passed. Great.
Okay.
So you want to do an assert that the count is 5? Maybe upgrade our test a little bit.
Let's see. Well, it's never going to be nil.
Right. The type system is letting us know that it'll never be nil. So I think that's probably fine.
Let's see. XCT assert equal.
Oh, hand.count.
Thank you.
Hand.count. Nice.
Okay. So now we're passing. So at this point, there's nothing in our test that says we need to have a type for each one of these until we determine that these things, like for instance, if I want to say pull out the high card, I kind of need a card type.
Right.
And so,
and we also want to limit the input, limit the sort of state space of what we're playing with. So if your card can just be any string of any length, then you could pass in the string Soroush and Ben.
Yeah, that's a good point. Yeah.
Whereas we really want to limit it to 2 characters of these 2 specific types. Like this needs to be a number, or like ace, king, queen. So
how about test parses cards as like a separate line of tests?
That sounds good.
Where we could say something like let card equals 5 of hearts.
Oh, nice.
And that we would say, let's see, card string.
Yeah.
And then let card equals card.parse.
Yeah, that makes sense.
Card string, something along those lines, and then I would assert that the the card's value is 5.
Yeah.
Let me do it like that, and that the suit is.
I would say dot hearts.
String for now.
You want to do a string for now? Okay.
I think that would take too big of a leap because I want to try and just create one type at a time.
That makes sense. Okay, string is fine.
All right. So now we've got a card.swift. That's very obviously a struct.
Right. Yeah.
Value is going to be an int, and suit for now will be a string.
And then we need a static function for parsing.
We'll have a static func for what I call it, parse, and then that'll take a string and return a card. And do we want it to just crash if it does? What do we want this to do, or throw?
I think it could just return optional. That seems easy enough. And then we can flat map out the optionals.
Yeah.
Yeah.
Okay. So I'll return nil just to get the program compiling. And let's see. Optional card not unwrapped. So here.
Right.
Can I do that? Will it figure that out?
It will.
Okay, good.
So actually, it doesn't like some part of it. Oh, it just doesn't like H is not equal to nil.
Yeah, because they're both nil.
Right. So the reason that works is there's a special overload for XCT assert equal that compares 2 optionals. And if either of them is nil, it'll return false. If they're both nil, it'll return true. And if they're both, some value, it'll compare the equality of the values.
Okay.
It works a lot like the equality operator for optionals, which is just specially defined.
Okay, cool.
Yeah.
Okay, so at this point, we need to extract out the 2 pieces in here.
So we could do parse, we could do basically string dot characters 0 and dot characters 1. That might be the easiest way to get this data out.
So the value part of this is going to be string dot characters 0.
Right.
And then the suit is going to be string dot characters 1.
Right.
And we've guaranteed that, it's not, we're never going to have a 10, right?
Right. 10 is represented by the letter T.
10 is a T.
Yeah.
Okay, so we always have one character.
Right.
And let's see, guard let string dot characters dot count
is 2. Yeah.
Is 2, else return nil.
You don't want to let there. You don't need a let.
Oh yeah. I do that every time.
It's too easy. I always forget the else.
Okay, so we have a problem here. Our value needs to be mapped to some value.
Right. Maybe the value is also a string, just to keep it easy for now. Because, ace is going to be represented by A. King is going to be K. So unless we want to represent it under the hood as a king is 13,
I honestly, I feel like there's another type there.
I think so too. Let's keep it string for now, and then let's do that type in the next step.
Yeah. Underlying everything, I want a number.
Yeah.
But I still like to represent it as ace.
Yes.
Or king.
Yeah. I think those will both be
Okay.
enums.
Oh, and I need to make these each a string, right?
Yeah, I guess you do. That's kind of frustrating.
What if I did substrings instead of characters?
Yeah, but then you got to do it with ranges, which could work.
That's not bad.
But no, I think you have to do, because I think that'll still return you.
Oh, it returns like
characters or whatever,
like a window onto the type or whatever.
View, yeah. I think let's do the screencast for now, and maybe in refactoring we can find a nicer way to do like substring from index to index or whatever.
Okay, yeah.
So that's good. You just need to pass like suit is suit, and then we need to go change the other test to
expect a
string, yeah, right? Instead of a number. Yeah. Now what are we missing here?
Let's see. Cannot subscript a value of character view with an index of type int.
That's super annoying. Can you do dot first and dot last?
Probably.
Those will be optional. Yeah. Can you just bang them for now and see if it works? Just put an exclamation point, and if it.
Well, hang on. It's.
Yeah. So that
init describing. Oh, that's where it's trying to find a different.
Exactly. Because if you pass in an optional. Okay. So the bang does work. So it seems like we want to.
I mean, it's not horrible because we have the guard in there, but it is horrible.
It's pretty horrible. Yeah. It seems like there's got to be a better way for that, but that test passes, which is good. Should we fix that bang first?
Yeah, I think, let me think about the way we could do this. Well, if we use substrings, we need to use this string.index thing.
Well, I thought there's like methods on it. Actually, I have a potential solution. What if we, go ahead, you say your thing first.
Okay, so what I was thinking is that our string has a substring method. And I can say to some arbitrary index.
Right. So you can do start index.
Yeah. So let's create basically. That. That would be let's see, string dot index, and then you need the start index. This is kind of annoying.
It's horrible.
And then it's offset.
Well, you can do index after. So I think that's probably a little easier.
String dot index.
And then a after, and then start index.
Oh, and I have to pass and start index.
Yeah, right, exactly. And that should be the splitting index that we want, basically.
Okay, that makes sense.
Yeah.
So substring to index, and then this one would be string.substring from index.
Yeah, that seems right.
Does that work?
Let's find out.
This works the first time. Oh my goodness. I didn't think that was going to work the first time around.
It's still pretty horrible and pretty annoying.
I like it better than having characters cast to strings with the bang.
I agree with that.
Honestly, and a scanner wouldn't necessarily make this cleaner. It would just be different because you would have things like scan int.
Right.
Which actually wouldn't work because we need to scan the character at a time.
Right.
Honestly, I'm not. This is fine.
Yeah, I think they said they're gonna take another look at strings in Swift for Swift 4. So I think they know that some of this stuff is a little unwieldy. Hopefully it'll get easier. Hopefully. But yeah, I think this is basically good.
So we've got our cards, and our cards are good here, except I don't like this at all.
These strings.
Yeah.
So I think we need two enums
in fact, both of these. So let's start with that. If we had another type, if this was like a card value,
right?
It was another type.
Yep.
So we would have another type that has an intrinsic notion of the output or rendering of a character. Of a card value. And then the underlying integer value that we could use for comparison.
Right. So I would actually make this an enum instead of a struct.
Okay.
Yeah. And do cases for 1, 2, 3 all the way up.
Let me think about that. All right. So, well, we have no 1. We have got a 2.
Well, you can't name them that. This is interesting, actually.
Yeah. Okay. So what if we had like a display, which is a string.
Right.
And an underlying value, which is in it.
Right. I would say that's good, but we should make one computed based on the other.
Yes. I was just going to do that in the initializer.
That sounds good.
So we take in a string.
Right.
And then we say self.display equals display. And that.
So you probably want this to be failable, the initializer.
Do we?
Yeah, because what if you enter the string Ben?
Yeah, you're right. Okay. So we expect this to be a single character.
Yes.
So guard display dot characters dot count is 1, else return nil.
Right.
Okay, so then we're going to switch on that display character.
Yep.
And in the case of we could do a case of. Well, I can't use a range of integers, right?
No, but you.
Yeah, I think I could do this. Okay, so let's handle the oddball cases. We've got T
Right.
for 10, so our value is going to be 10. We've got J, and we've got Q for queen, which will be a 12. King will be a 13, and an ace will be 14.
Should it be 1 or 14?
Well, in poker, ace is high.
Oh, okay.
Yeah, so we couldn't use this for another card game unless we made a notion of what ace is high or low.
Right. That's true.
Okay, so in the default case, we are going to...
Oh, I see what you're going to do.
We're going to just like try to cast it to an int.
Right.
And that should return an optional, right?
Right.
Let's see, if let int value. Let me call it digit.
Cool.
Then we can say value is digit.
Yeah.
Otherwise, return nil.
Yep. That seems reasonable.
Okay, so at this point now, card can't be computed unless it has a card value.
Right.
And where was I? Card has a card value. And honestly, I want value. I don't know how you feel about exposing this as an int and then having like a internal type of card value.
I don't mind.
Because, and the reason why I'm doing that is that here I could say create a card value with this display. So I pass it in properly. And then here in the getter, I can return card values.value.
Right. If we end up needing card value.value to be exposed on card, I'm down, but we don't actually need that yet. And in as much as possible, I want to see if we can push down all those comparisons and calculations into the card value itself. So no matter what, it has to... oh, I see.
So this one needs to be an integer, and I need to be able to... I need to be able to say card value. I'd want to be able to say... See, this seems weird to me.
Yeah.
.value. That's why I was thinking .value to return the int, or I could do .card value to get the card value
itself. Interesting.
Otherwise, in order for me to do the comparison, I need to do card value display 5, which
what is that even doing in terms of the test?
Yeah.
Yeah. And we actually don't have equality operators for that yet anyway. Which we would need.
Okay. So I think the int is the easiest.
Yeah. Okay. Let's do it that way.
Solution for now, and I want to avoid doing .value integer value or whatever.
Right.
Because then you're reaching into another type.
Right.
One benefit of doing this is that this is almost private.
Yeah.
Because then at that point we have a value which is an int that just delegates to card values value.
Yeah. My only worry here is that our ints basically, like, the only thing preventing int from being any value in any state space is the fact that we have this initializer elsewhere. It's like if somebody came along and refactored this class, they could get rid of all of the limitations and constraints that card value places.
Oh, I see what you mean.
Yeah.
So we could theoretically construct this.
Yeah. I maybe
actually we have no initializers.
Well, we have the member-wise one that we get for free.
Can we disable it?
We could, but then, you want to only be able to access it through parse. Oh, that's an interesting idea. We can disable it.
Because I don't think it's valid for you to ever... Because this is private.
Right.
Then at this point, what does the member-wise initializer give you? Just suit? And then how would you ever construct it? I think that because it's private, we don't even get one, right?
No, I mean,
right?
it's working, right?
I can't do that.
Oh, right? No, it's not incorrect argument label. Yeah. No, wait, that
should have value in suit, but how would I do that?
So it does work. It's just that the exposition...
It takes it, but then I can't read it later.
Right, exactly. I think if we play with card value as its own, like on its own terms, I think that's going to be the best thing. And like, let's just implement the equality operator, because that way we're not overloading int to mean other things. We're basically dealing with our domain in the context of itself, rather than trying to shift our domain into something that we find more manipulable, or Swift gives us more tools to manipulate. Like if we want to be able to add two cards together, we should write an add function instead of relying on the fact that it's backed by an int.
Okay, that makes sense.
So I would say
so we're going to get rid of that. We're going to move this back to value.
Yep.
What about the integer literal stuff?
What do you mean integer literal stuff?
Hang on, let me do a quick search.
Oh, integer literal initializable? Or
let's see. There's another type that I can search for real quick.
Integer literal convertible, I believe is what it's called. Oh, sorry. Expressible by integer literal?
Expressible by integer literal. Yeah.
Yeah, it used to be called integer literal convertible. So, but this is only good if you're dealing with literals, which we're not. We are dealing with...
Yeah, I think it is, right? This thing, if I compare this with a 13, it should work.
Oh, that's a great idea. Okay, cool.
Okay,
yeah,
so,
I totally missed that. Yeah.
What is the method that we need here? We need another initializer.
Exactly.
That takes the integer literal, which is an integer literal type. I don't know what that is.
You declare it. You declare that's like an associated type. So you could just write int there.
Oh, okay.
Yeah.
Type alias.
Yeah.
Oh, do I have to?
You can get it for free if you just write int there. Yeah.
Okay. Cool. That's interesting. So you can come at it from both ends. You can perform the type alias, in which case it knows what it is. But if I define it here, then it knows what the type alias is.
Exactly.
Interesting.
But now we have an interesting situation where our display is like, how are we going to get our display?
Well, we can do the reverse, right?
Yes, but then
here I can switch on the integer literal.
Right.
Well, here I want to guard. This can't be failing.
Can't it?
Well, I don't own this constructor, so I can't.
Right.
What do I do in this case?
Yeah.
I think that let's see. That means somebody could create one that doesn't exist.
Right. Well, yeah.
But maybe that doesn't matter. Maybe like I think that we can create it in the case that we need it.
If we just,
card value isn't really useful on its own, right? It's only useful as a part of the program. Anyway, what I was going to say here is that let's just assume that it's valid for now.
Right.
And then I can say, give me that. And then I can say switch on the value. And in the case that we are 2 up to, but not including 10.
Right.
Then our display is just the string representation of that value.
Yep. You need an equal sign instead of a colon there.
Oh, yeah. And then we would just need case 10. Display is 10 or T.
Yeah.
For 11, display is Jack. Okay.
Right.
So the downside of this is that now you can create one that doesn't exist.
You actually need a default
so maybe that means that we don't.
Because what if it's not in that range? Yeah, you need a default.
Yeah, but let's just, you know what? Guard integer literal.
Well, do this.
How do you test that it's in a range?
You would say the range contains.
Okay, so then we'll do 2 up to and including 14.
Dot contains. Yep, that's it.
That, else. Fatal error.
That works.
This is horrible, but out of bounds.
So I would actually say the best thing to do here is instead of, because your switch is not complete, so you need a default case in your switch anyway. So in your default case, why don't you just do the fatal error there?
Okay. Yeah, I could see that.
Yeah. And then you can just kill that guard.
Yeah. So now we're back to protecting our input.
Yes.
And back in our test, the card's value should be convertible to 5.
Yes.
Let's see. I think I have a problem. What is it complaining about? Value of optional type card value not unwrapped. Oh, that happens here. So this guy, we would just have to say if let. So if we have a card value, then we're going to also grab the suit, return the card like that. Otherwise, return nil.
Yeah, sorry.
Okay, now it doesn't understand about card value being equatable. So in this case, we've expressed it as an integer literal. So I can then go in and say card value integer literal 5. But it also doesn't know what equality means for card values, right?
Right. And it should promote that 5 to a card value by itself.
Yeah, you're right. Okay, but we just need to implement equality then, right?
Right.
Okay. So I'm forgetting how to do this.
So
exactly.
Inside the type, you would do static func equal.
Do we have to conform to a protocol?
We will, but we'll do it after.
Okay.
And I think you need a space after the func, but before the operator itself. And then LHS is card value, RHS is card value, and it has to return a bool. I always leave out that return a bool, and it's like, you don't actually conform to equatable. And I'm like, come on, yes, I do.
All right, so in this case, I just delegate to the internal value is equal to that.
Yeah.
Okay, and so then
now you
just
conform.
Like an extension.
Yeah, you could do it that way, or you could do it at the top, either way.
On
card value
equatable.
Yep. And if you want, you can actually move the static function to that as well. It's kind of a stylistic thing. It'll work either way.
Okay.
Yep, that should do it. Nope, it didn't do it.
All right. Cannot invoke initializer for type card value with no arguments. Where did I do that? Oh, it got past our test down to here. All right. Sweet.
Perfect.
Back to passing.
Nice. And now we got to do the hearts.
Okay. So now we've got cards. Now we just need to make sure that player hands, which I misspelled here, has cards in it.
Let's do the suit enum first, since we're kind of on that track.
Yeah, that's an easy one.
Yeah.
All right, so let's, and I'm going to move card value into its own file.
Seems good, yeah.
Doing that. And suit. All right, this one, I could see this being an enum, right?
Yeah, for sure.
So we've got a case of, let's see, hearts.
I would actually label it all the way.
If we do string,
right,
then we get the raw value for free.
Yes. So I would spell it out.
Spade. And then just write our own initializer?
No. So if you do hearts and then you put an equal sign and then you put like H, like just like that, that'll work.
Oh, I didn't know that.
Yeah.
Spades equals S. Oh, that's awesome.
Yeah. You wrote spaces instead of spades.
And clubs.
Yep.
Okay. Really bothers me that those are not indented. Okay.
And then we need to use those.
Also, it would be kind of nice if, let's see, what is it? Custom string convertible?
Well, so do you want...
you can have a description?
Yes.
I'm just doing this because I feel like I should.
Yeah. And then we also probably want equatable for this, and we'll probably... Yeah.
And then here, I just want to return.
Emoji time.
Yes. Maybe it doesn't like the emoji.
It's certain fonts use slightly different representations. So if you outputted this in Helvetica or whatever, it would come out, I think, as the thing you expect.
Okay.
Or San Francisco or whatever.
Yeah. And it's fully specified. So cool.
Yep.
Nice. Let's see. What am I missing here? Oh, return statements on all these.
Right.
I've been doing too much Ruby.
Well, and it's weird because Swift will let you omit the return statement sometimes. And you need colons instead of equal signs on all those.
Yep. And dots?
Dots? I think they were optional at some point, but I don't remember anymore. Expected declaration. What does that mean?
I think I have a compiler or something.
Oh, you're missing a brace. The brace for description. There you go. Sweet.
Okay.
So
you're saying these used to be optional?
Or maybe they still are?
No,
they're not optional. I think they were optional in Swift 2 or something like that. I forgot.
Okay, so now in our card, when we're parsing the suit, we also need to unwrap. I'm never satisfied with the indentation of multiple lets. I don't know what the appropriate one is. So this would be suit with a raw value of this.
Right.
Which I'm not liking.
So I think we can maybe do a little bit better than this, than the if let. If we move this optional check into the card initializer, I think we'll get some wins.
Okay.
So
let me get this to compile.
Right, that makes sense. So you have an extra paren between raw value and the colon.
Oh yeah, there it is.
Yeah,
that's what was throwing me off. Okay, does this compile?
Suit.
It expects a string now,
right?
And it's not a string,
right?
So we need to go back to card. No.
Yeah.
Yes. Sorry. Okay.
Still nothing. Now the assert is broken.
Which I can easily fix now and just say .heart.
Yep. And still... Oh, are they not equatable?
It's an enum. It should be by default. Let's see. Is it because it's optional?
No, it might be because it's not specified.
Oh,
so
it doesn't understand it because it's optional. Yeah.
Try that.
If it wasn't optional, I think it would figure that out.
That's odd.
Let's just verify that.
Huh. That's super weird.
I think it's because what you're talking about with the optionals.
Right.
The optional implementation of that is too generic to understand.
Gotcha. So kill the bang, add suit back, and then we should be good.
Yeah.
Nice.
Suit.hearts. Okay. And now, just because we can, custom string convertible, now we can have a description string here, which just returns the values.
Display, right?
Display. Well, value, honestly, it should just be...
value should be its own custom string convertible. Yeah.
Yeah. I guess I'll do that in extension.
Yeah, that works. Nobody really knows where this this stuff should be happening.
I only did in this file because I already did it
Right.
once. Okay, so var description, string, and this will return display.
Right.
Why does it know that? Because I'm in an extension. Is that right? No, extension card value
Right.
is... Oh, I can't even Vim.
And then I think you lost a closing brace.
Static methods may only be declared on a type. It is on a type. Let's see, look at the very first one. I think...
Oh, you're...
still missing a closing brace?
You're missing a colon, it looks like. So go to struct card. Go to the card file. There, that should be a colon instead of a comma. Wonders of pair programming.
Yeah.
Do we get it?
I don't know. Scroll down to the
there we go. Nice. Cool.
Okay, so now if I print out the card, print card, we should see 5 of hearts in the output. And
it's because it's optional. So you have to either do a bang or do as any.
Yeah, okay.
5 of hearts, there it is.
5 of hearts.
And there's the emoji too.
All right.
So let's go back to card. And my thinking here is that if we have a optional initializer that unwraps value in suit for us, it'll be a little bit cleaner than the way that we have it now with everything in the parse function.
Yeah, and it's all in the same file anyway.
Yeah.
So we get to have a init with optional card value.
Yep.
And optional suit.
Yep. And then we'll do a guard, and then guard the value equals value, suit equals suit. Or I think you need another let now as a Swift 3.
Yeah.
And then just a simple assignment.
Self.value equals value.
Yeah. Perfect.
And now we can just get rid of that.
Well, not quite, because you...
Oops. Yeah, I need this part of it.
Yeah. And that's good.
Oh, that's so much better.
And I would even move the suit string to be in line with the... Well, once we get it to work.
You mean because this one is also...
just to make just for symmetry's sake. Okay, what's the problem now?
Let's see. Expected expressions let suit raw value. Oh, I'm missing a closing paren there.
Sweet. That seems...
Oh, that is so much nicer.
Yeah, that seems super clean.
So much better.
Cool. Yeah. Awesome.
Okay, so I wanted to try to end off. We're running a little long, but I wanted to try to end off and sort of be able to pick a high card from...
We're very close. We just need to parse. We need to flat map the hand strings into actual...
Yeah.
So go to the parser.
So right here, I would... let me think.
Or I guess if you want to write the test first.
Test parses player hands. Yeah, so what I would want to do here is expected hand is going to be an array of cards.
Right.
And so I should be able to say...
Well, do you want to do card.parse?
Because we already have a test that verifies that?
Yes. Yeah.
It's also
just
more
shorter,
succinct. Okay, so the expected hand...
3D, 5S, 9C, and KD. Cool. And then flat map out the nils. Okay. Yeah. So two notes. I would add that trailing comma back, actually. The reason for this is in a diff, poker hands are always 5 cards, but in a diff, if you were to add more lines there, it would clean up the diff because you wouldn't have to go back and add an extra comma.
Wait, is that a valid array?
Sure is.
Oh,
yeah.
It's not in other languages.
Those languages are broken, in my opinion. And I
will agree with you about JavaScript. Yeah.
It is valid in JavaScript, but not in functions in JavaScript, I believe.
Okay.
But I would also flat
yeah,
map
that's
out.
Interesting. Yeah, I like that.
I would also flat map out the nils.
Because card.parse is...
returns optionals, yeah. So just flat map $0. Yeah, that should do it.
Okay, so then we're going to assert that our expected hand is equal to...
Hand.
And hand isn't going to work because it's an array of strings.
Right, yes.
So now we go back over to player. Hand is now going to be an array of cards.
Nice.
That doesn't work because our parser is no longer doing that.
And this should just be a pretty straightforward flat map.
So we'll do let hand is card strings, map, right?
Flat map so you can take out the nils.
Doesn't that... So these are not nil at the moment. Right. So wouldn't flat map only take out the nils of the receiver?
No, it will do the conversion and then take out the resulting nils.
I didn't know that.
Yeah.
Okay, so so we're going to flat map over all of the card strings.
Right.
We're going to delegate to card.parse.
Right.
In fact, I can just give it the reference to that function.
Oh, that's great. Look at that.
And this will automatically pull out all the nils?
Yes, sure will.
I love it. Okay, let's see. And now we can't do equality because it doesn't know about equality of cards.
Right.
So this should be pretty easy. I'm going to do that again in an extension for card, which would be equatable.
Right.
Then we'll have the static func equal. Left-hand side is going to be a card. Right-hand side is going to be a card. Returns a bool. And then here we just want to return that the left-hand side's value is equal to the right-hand side's value.
Yep, and that the suits are equal.
And left suit equals right-hand side dot suit.
Perfect. Tests are passing.
And it passes.
Great.
Okay. Oh, we are so close to our stated goal. So let's see. Test detects high card.
Yeah, that works.
So given that input, I expect the king of diamonds to be the high card.
Right.
And then given that I have a hand, I think I just want to, like, rather than rely on the parser
Right.
here.
Yeah, that's probably smart.
Just say, give me a hand like this, flat map. Let's see. I'm just going to do that because it's a test. And then we don't really have a type to do this, but I'm just going to call it poker.
So it might be easier if we just did hand.max.
Well, I want to delegate this logic to a type that can like I'd be able to say, I want to be able to say poker.pair or, find pair or something like that.
Right. I see.
Something like that. Like you take in a hand, the shape of this is you take in a hand and you get some T.
Uh-huh.
And that T changes based on what the result is. Like high card obviously is going to return a card.
Right.
Which card was high. In fact, it doesn't even matter. It could be a card value that you return.
Well, the suits also have an order, don't they? Because spade is the best. Oh, not in poker. I see.
Not in poker.
There are some games where it does.
So for two high cards that are the same, different suits but the same value, that's a tie.
Right. Okay.
And for two pair, we need to know so first of all, for pair, we need to know what the card value of the highest pair was.
Right.
Same thing for two pair. I need to know two card values.
Uh-huh.
I need to know the card value of both of them so that I can judge between the two.
Gotcha.
Let's see. Poker.flush would just give me a suit and a high card, right?
Yeah, I think that's right.
I don't even care about the suit.
Before we get to all that,
I care about the high card. I'm just thinking out loud that I need different types of return types for each one of these methods, which makes me think that this is going to return like an enum with associated types.
Yeah, that makes a lot of sense. But I would argue, even if all that's true, your card still makes sense to make comparable. And then if you want to find the high card, just do hand.max. You don't even need to talk to another type. And your poker type will eventually use card.max to like figure stuff out. Okay,
so literally you're saying
hand.max should be the code.
XCT assert equal. Well,
and then,
but we still want to delegate that to a type.
But yeah, I guess
like just a place for all these functions.
Right.
Yeah, I guess I'll start off with what you're talking about, and then we'll just move it if we need to.
Yeah.
So expected high card, hand.max.
Yeah, and you can remove that bang now too if you want. And then we need to make card be comparable. Which should be pretty straightforward.
I forget which one I
normally do it like you have it right there, like comparable, not like equatable. That's how I do it, but it's also totally purely.
Well, I just need to be consistent because now I'm forgetting what I normally do. Okay, so this I'm assuming that now we just need to do like func less than.
Yep, that's all you need.
Card, right hand side card,
and
turns blue.
Yep,
and it'll. What about less than or equal to?
So it'll calculate all that stuff for you. So if it's less than and equal to, it'll give you that for free. If it's greater than, that means it's not less than and not equal to, and so on. That's it.
Right hand side dot value.
Yep.
C cannot be applied to card value.
So it has to be like,
card value needs to be comparable also.
Right. Yes.
So that's pretty simple.
Yeah. Yeah.
And this is going to be.
What did we call it? Value? Yeah, I think we call it value.
Yeah.
So just
So this is card value.
right. No.
Wait, I still called this one value. That's a little confusing.
Right.
But
yeah, now you got to jump to card value and make it comparable.
I did that.
I don't think you changed the names of the types. The card and card. The left-hand side and right-hand side, yeah.
Yeah, you're right.
And
so that's
hand up max needs parentheses.
Yeah. There's my Ruby showing.
There you go. I make that mistake all the time too. There we go. Nice.
Wow, that's cool.
Yeah.
Okay, so finding a high card is now just going to be essentially this code moved somewhere else.
Yeah, eventually, we can move that code elsewhere, but like the basic code is pretty straightforward.
Okay.
Yeah.
I like this.
Yeah.
I like this a lot. I think the way we did the card cleaned up quite a bit.
For sure. And
the way we did card value, I'm not super happy about the fatal error, but
right. So
aside from that, I think it's nice that you can convert them to integers.
On card value, I think there's two interesting notes. One is that the integer literal conformance we're actually only using for our tests. So we could actually even move that to the test target if we had two targets here. I don't know if we do or not.
Oh, and then I wouldn't care about the fatal error.
Then you don't care about fatal error, right? The other thing is, well, and if you do move this, then that would be fine. But right now we have basically the same logic twice in this switch statement.
Yeah.
And I think there's some ways we could explore making it.
Just thinking out loud, I could easily see a dictionary lookup.
Yeah, something like that.
Something like that, and you just reference it from both
places.
places.
Or if you look at suit, if you take a look at the suit file, that's basically what this raw value situation is.
Okay.
Yeah.
So in this case, then if we did card value as an enum,
right,
then we'd have a case of 2.
Yes, exactly.
Which would be an int, and then we'd have 2.
And then we would still need a switch to convert the numbers to some kind of lookup to get from the strings and back. So I would actually maybe say it should be a string, and then the value is a switch based on the enum type, something like that. But either way, it's kind of a lot of code. I'll think about if there's any way to make it more elegant, but it kind of seems like you're going to need 2 switches either way.
Well, cool. This was super helpful.
Yeah, I thought this was
I'd
great.
like having a second pair of eyes on it. So I think this is a good place to stop, and we will pick this up again next week.
Sounds good. Cool.